Next, we'll see the various types of wind generators. Mainly, there are two types of wind generators used in the wind turbine. First is synchronous generators. Second is asynchronous generators. The synchronous generators are again in two types. One is having the permanent magnet, permanent magnets on the rotor. Second is on the rotor there is a winding, and it is called wound rotor, and which can be controlled excitation. DC voltage can be given. Basically, synchronous generator, it is a synchronous electromagnetic machine used as a generator. Magnetic field is on the rotor and stationary stator with a three-phase winding. Here, what is happening? The rotating magnetic field is created either on the permanent magnets, which are directly mounted on the rotor, or with the electromagnetic field, which is given externally by DC current. So as we can see, as the rotor rotates its magnetic flux, it cuts the stator coils, and as we all know, by the Faraday's laws, an EMF is produced in the stator winding, and current is induced in the stator coil. So second type of generator is called asynchronous generator. So in asynchronous generator, first type is squirrel cage rotor, and the second type is called wound rotor. So wound rotor is also again in two types. First is called double fed induction generator. It's called doubly fed induction generator, and second is variable rotor resistance. So we'll see first what are the synchronous generator. So as I told, this wind turbine using the synchronous generator either with a permanent magnet or electrically excited rotor. So this synchronous generator can be connected directly or without or through gearbox. But basically, in the present scenario in the industry, the synchronous generators are generally directly coupled to the generator. So sorry, this hub is directly coupled to the generator without the gearbox. So this is the schematic diagram of the permanent magnet synchronous generator. So this is the wind turbine. So these are the blades. This is the hub, and this is directly connected to the generator. It's called permanent magnet synchronous generator. So here there is no gearbox. So whatever is the low RPM of the rotor, which is in the range of maybe say 10 to 15 RPM, which is directly coupled to this synchronous generator, and then the output of the generator means there are two coils. So there are coils on the stator winding. So this stator winding is given to the one rectifier, which converts the voltage generated by the permanent magnet synchronous generator to the DC. So here what we will get will be a variable. As the wind is not constant, wind speed is not constant, we will get variable DC voltage with in this rectifier. So this variable DC voltage is again, this is a step, this is a DC bus. Again, this is a filtration capacitor, and here also there is a step up booster, DC booster is circuit also there to boost the DC voltage to a typically 600, some say 600 DC voltage, which is at the output of this DC bus. So this constant DC voltage from the output of the DC chopper is then fed to the inverter circuit. The main purpose of the inverter circuit is to convert this DC voltage to a fixed AC voltage. This voltage is around 690 volts at 50 hertz, which can be connected to the main grid. Main grid, of course, there will be a step-up here the grid, before grid, there is a step-up transformer, maybe from 690 volts to around 22 kV or 33 kV, depending on the grid voltage. So here, so to control this thing, there will be a control system for both rectifier circuit and the inverter circuit. Ultimately, all this control circuit is controlling the total wind turbine, all electronics, this is being controlled. So this is again a synchronous generator. Only difference in this is instead of permanent magnet, here the coils which are mounted on the rotor are being excited. DC excitation is given from the external circuit. So from the grid or output of the stator is again getting tapped with a small rectifier, and this controlled DC voltage is being fed to the DC excitation from the rotor. But only thing here, there will be slip rings and these things. So there will be some issues like wearing out of the carbon brushes and other things. That's the reason more popular there are permanent magnet machines are being used. So as I told, the electrical frequency of the generator may vary as per the wind speed, and this frequency of the power converter is matched with the grid frequency. So ultimately, the power, the RPM of the synchronous machine is directly proportional to the what is the speed of the blades. So this is given by the formula, as we all know, 120 F by P. In this case, all the synchronous machines will have a number of poles on the very higher side. It can go up to say 60 to 80 or even 90 poles will be there, so that say in case of standard RPM of say 15 RPM of the rotor and with the poles of say 88, and so output frequency can go up to 11 to 12 frequency can go, and then voltage can be around 600 or 690 volts. It can go at the rated RPM. So difference, this thing, permanent magnet synchronous generator and this wound rotor requires less maintenance as it is directly coupled, and the speed of rotation is very less, is around 8 to 15 RPM. Also, the efficiency of this turbine is slightly higher than the asynchronous generator. As I said, the low speed direct drive permanent magnet synchronous generator is more being used, and it can have a direct number of poles. It can, on the rotor, it can be much more than 60 or much more. The second type, as we can see, it is the induction motor, and we'll see here the double fed induction generator. It's called also the doubly fed induction generator. In this double fed induction generator, yes, in this we are having both rotor and stator. Here the turbine is here. This is the turbine. Here we are using the gearbox. Gearbox is in the ratio of say 90 or 100. Say for example, the RPM of the turbine is approximately say 15 RPM. If the ratio is 100, this rotor is moving at the RPM of say 1500 RPM. So with the 4-pole rotor, 4-pole synchronous or asynchronous machine, this will have a 1000 RPM induction generator. So this will have both stator winding and the rotor winding. And in the main important of this thing, this we can give, this rotor will, here we can give fed power input also, and we can possible to get power also based on the speed of the rotor. If the speed of the rotor is less than the synchronous speed, then in that case, what is happening? We have to inject the power in the rotor circuit, and the voltage is at the typical frequency we have to apply here, so that we can get output at the synchronous speed from the stator. So again, this stator is having the output is directly coupled to the main grid. So here the AC to DC converter system, the capacity of this AC to DC is not full power. Say in example, in the synchronous generator, the capacity of the inverter has to be full power. Say example, if we are having the wind turbine of say 2 megawatt example, the power electronics, all the things converter has to be for the total 2 megawatt power. It should have control all the 2 megawatt power. But in this case, only 30% of the power is being fed or handled by the rotor, and direct 70% is being handled by the stator. So here stator is direct, as it is directly connected to the grid. So this is not requiring any power electronics or AC to DC converter. So this is the main advantage of the double fed generator, which the power can be fed in the rotor from the both sides. If the speed of the rotor is below synchronous, so the power is fed to the rotor, and if the speed is in the super synchronous speed, the power is also, we get the power from the rotor, and again it is fed to the main grid. And as we all know, induction motor, induction machine will operate as a motor only when it is above the synchronous speed. Of course, this motor or this machine we can use both as a generator as well as a and also as a motor. Depends on what is the speed and how we are applying the voltage, and whether the rotor is moving or we want the mechanical power. As I said, the stator is directly coupled to the grid and the rotor is connected to the power converter. So this DFIG generator can operate at a variable speed that is below and above asynchronous speed. The rotor produces, of course, reactive power when the speed is increased, and the synchronous speed and power is fed to the grid. The power converter, as I said, the power converter in this turbine is rated at the lower power at about 30% of the wind turbine's rated power. This makes the wind turbine cheaper than the synchronous generator. Here, then we'll see the difference between gearbox versus direct drive wind turbine. Mainly, as we have seen, the machines which is having induction generator are having the gearbox, and the synchronous machines which are working at a very low RPM are having direct drive machines. So gearbox converts the slowly rotating high torque power from the wind turbine from the slow speed to high torque power. The gear ratio can be typical 90:1 or 100:1 for 1000 RPM generator. But there are some issues in the gearbox wind turbine, as we know. Basically, all gearbox is an inherent tendency for oil leakage, and it requires a high maintenance. Of course, there is a slight loss, power loss will be there in the gearbox. Definitely because of that, the efficiency will get decreased. And always the gearbox are so heavy, so the weight of the nozzle will increase. And of course, the noise will be much higher than the gearless machines. In the direct drive machines, the hub is directly coupled to the generator, hence the rotor is rotating at speed at around 15 RPM. Of course, with this, it offers the below this thing good things. It is having the better efficiency, better reliability. It will have a low maintenance. Of course, it will have low noise due to low speed of operation. But of course, it is having the slightly higher cost as compared to the direct with the asynchronous machine like DFIG. Now we'll see how many are the top wind manufacturers in the world are in India. The top wind manufacturers in the world are Vestas. It is based in Denmark. The second topmost is Siemens Gamesa. It is based in, the main headquarters is in Spain. One more thing, company is called Goldwind, is based in China. Then it's called GE. It is based in the USA. Then the Enercon is from Germany. Envision is from China. Nordex is from Germany. Mingmang is also from China. And the top countries which are manufacturing or is having installed capacity all over the world, the first name, as we all know, is China. Second is USA. Third is Germany. Fourth is India. And fifth is Spain. So we are really proud that India, even though it is a small country, but it is a very good developed country. It is the fourth top countries having the almost 40 gigawatt power installed power in solar as on today. Then the top wind manufacturing companies in India. In India, we are having Siemens Gamesa. Second is Suzlon. Third is Regen Powertech. Then Inox Wind. Then Vestas, Nordex. Of course, Siemens Gamesa and Vestas and all these Nordex, even though they are from the other parts, Germany or other things, they are having the manufacturing, set up the manufacturing plants in India. Now we'll see what are the key parameters of the wind turbine. The main key parameters of the wind turbine are from what is the capacity of the wind turbine. So earlier in the earlier days, maybe 10 years back, it was even 250 kilowatt or even 500 or 750 kilowatt was there. But now in the present, this thing, even we can go, we are having machines from 1.5 megawatt to around 6 megawatt. Even in India also, there are companies, we are having even 4.4 or 5 megawatt machines are also installed. Then in that case, the rotor diameter can go up to 87 to up to 150 meters. Then what is the cutting speed? Cutting speed of generally for all the wind turbines is around 3 meters per second. So cutting speed is the minimum speed of the wind at which the wind turbine can start the giving the power. Then comes the cutout speed. Cutout speed is generally in the range of 25 to 30 meters per second. About 25 meters per second, even though we can make power from the wind turbine, but it is generally said we have to stop the wind turbine even though the wind is very high, because if the wind speed is more than 25 meters per second, there will be huge vibrations and it is likely to damage the wind turbine. Height of the hub height. What is the hub height? Hub height is the height from the hub center to the bottom ground. It can go from 60 meters to around 140 meters. We can, in the present generation wind turbines are having the height up to 140 meters we can have. RPM of the rotor can go up to 10 to 18 meters revolutions per minute. Generally, the life cycle of wind turbine is around 20 to 25 years. And even the manufacturers are having the operational guarantee or operational warranty, I should say. They are giving the operational guarantee or the operational service for around 20 years. And there are various types of wind turbines based on the IEC standards, say IEC standard 1, 2, or 3, based on the average speed in the installation site. So if it is IEC class 1, so speed of the wind is more than 10 meters per second. That is the average speed for the last, I should say, 5 to 8 years. And for class 2, it is around 7.5 meters. And for class 3, it is around 5 meters. Then it comes the machine availability in hours. So this terminology is called number of hours the wind turbine is available without breakdown, and in that case the power is fed to the power generation. Then comes the capacity factor. Basically, as we all know, wind is not even for all the total 25 hours or even all the 12 months in a year. Mainly, if you consider day and night, it is more in the night time as compared to the day. And particularly if you see the seasons from April, May, June up to September, the wind velocity is quite high, and almost 4 months, around 75% of the wind wind power is being produced. So, so this factor is called the actual output as a fraction of full capacity. So generally, this is between 15 to 30%. If this factor is around, even if it is 25%, we can see, we tell that the wind machine is very good. The next factor is called grid availability in hours. So it is the number of hours the state board common grid is available. Say for example, if the common grid is not available, then in that case the wind turbine working is of no use. We have to stop the grid for that reason. Then it comes the export of the power. How much kilowatt power is being exported to the grid. Then how much power we have to import from the grid. Basically, this power is being consumed by the fans, heaters, yaw motors, and hydraulic pumps. Now we'll see what are the various job opportunities in this wind industry. Wind industry is the only industry where almost all types of faculties or all types of engineering graduates or even other things have the scope in this manufacturing, the wind turbine industry. So even for a civil and structural person, for it is the turbine foundation and the approach roads, the civil engineers can be they find their jobs. Mechanical and fabrication engineers find in the tower manufacturing, then gearboxes and all fabrication items used in the wind turbine, mechanical engineers are being used. For electrical engineers, for all the generators and all electrical systems, substations, electrical engineers they find in the wind industry. Electronics, for all automation, control panels, power electronics, electronic engineers are being recruited. Computers, computer engineers for all SCADA, communications, everything for these engineers. So almost all faculty, all engineers and all these things are you can find jobs in the wind industry. Then in the production engineers in the wind turbine manufacturing company, quality engineers in the project sites, project engineers at sites, erection and commissionings of the wind turbine. Also, we can find engineers and wind data analysis, then operation and maintenance engineers at sites. Also, there is huge potential for wind potential assessments, preparing the feasibility reports before selecting the sites. So finally, in this webinar, we have learned the basics of wind turbine, how wind renewable energy is produced, and ultimately in the wind is becoming very increasingly important in the present generation or electricity generation, and wind turbines are getting bigger, taller and more efficient. In the last few years, we definitely we can see a much more improvement in the wind turbine. Even now, offshore wind turbines are being, yes, earlier in the Western countries, they were used maybe 5 to 8 years, even they have started, but even now also in India also, they are planning to install in the offshore. In there is huge potential in the wind turbine in even offshore. Only thing offshore, the capacity will be much more higher than the onshore machines. The offshore machines can go more than 6 megawatt machines, but only thing, the maintenance of offshore is very, very costly. But for that only thing, generation point of view, we can find a huge potential in the offshore machine. So with this, I have concluded my webinar.